Hello guys, welcome back to the universe of Tech Hub. In this tutorial, we will learn about insertion sort. First, we will learn about what is insertion sort. Insertion sort is a simple sorting algorithm that builds a sorted array, one element at a time. It works by taking each element from an unsorted list and inserting it into its correct position within the already sorted portion of the list. This process continues until all elements are sorted. Insertion sort is particularly efficient for small data sets or when the input array is nearly sorted. Insertion sort is a way to arrange a list of items in order. It like a numbers or words like that. It works by building a sorted part of the list, one item at a time. Next, we move on to the why is it used. Insertion sort is used for it is easy to understand and it is easy to implement. This is the reason why insertion sort is used. Efficient for small data sets or partially sorted array. This is also a reason for why insertion sort used. It performs well when the data is mostly sorted and it is a stable. It preserves the relative order of equal elements in place. It requires only a constant amount of additional memory space. This is all the reason for why insertion sort used in data structures and algorithms. Next, we move on to the application. Applications of applications of insertion sort. Insertion sort is used for small data sets, like ideal for small data sets where its overhead is minimal. Insertion sort is used for small data sets and also used for online sorting, when data is received in a stream and needs to be sorted on the fly. Next, we need to use it in the partially sorted data, effective for data sets that are already partially sorted. Next, we use it in the educational purpose, like that in computer science due to its simplicity. I'm taking one example. Sorting a books on a shelf. Imagine you have a few books that you want to arrange on a shelf in alphabetical order. The process, start with the first book since it's the only one. It's already in the right place. Take the second book and compare it with the first. It comes before the first book alphabetically. Place it in front. Otherwise, leave it as is. I hope you understood. For the third book, compare it to the first two. If it comes before the first book alphabetically, place it in the front. Otherwise, leave it as is. For the third book, compare it to the first two. If it belongs before them, place it in the correct spot, shifting the others as necessary. Next, we continue this process for each book until until this is an example for how insertion sort works. Next, we move on to the algorithm. First step of the algorithm is this is start from the second element, index 1 of the array. Start with the first element as a sorted subarray of the length 1. Next, second point is pick the next element from the unsorted portion. Like start from the second element. Next, set the current element as the key. Compare these elements with the elements in sorted portions, shifting each element one position to the right until the correct position is found. It means compare the key with the elements in the sorted part of the array to its left. Shift all elements that are greater than the key one position to the right. Next, insert the selected element in its correct position in the sorted portion. Insert the key in its correct position. In this sentence means insert the key in its correct position. Next, repeat the steps 2 or 4 for all remaining elements. Repeat until the entire array is sorted. This is how insertion sort algorithm works. First, we need to start from the second element like index 1. Next, we need to set the current element as the key. Next step is compare the key with the elements in the sorted part of the array to its left. Next, shift all the elements that are greater than the key one position to the right. Next step is insert the key in its correct position. Next, repeat until the entire array is sorted. This is the algorithm for insertion sort.
This is the visualization of insertion sort. I have to take the element as 5, 2, 9, 1, 5, 6. It is showing how insertion sort going. It's all about the how insertion sort works.
First, I need to take one example for insertion sort. Like the array will be 5, 2, 9, 1, 5, 6. This is the example 1. First, start with the first element. The first element is 5. Is considered as sorted since it is the only element in that part of the array. Sorted part 5. 5 is the sorted part. The unsorted part is 2, 9, 1, 5, 6. Next, insert the second element. Take the next element. 5 next element is 2. And compare it with the element in the sorted part. 5 is the sorted part. 2 is the unsorted part. Compare the 2 with 5. Since 2 is less than 5, yes, we insert it to before 5. Insert it in the before 5. Like 2, 5, 9, 1, 5, 6. In this, 2 and 5 are the sorted part. 9, 1 and 5, 6 are the unsorted part. Next, we move on to the next. Insert the third element. The next element is 9. Compare it with the sorted part. Like sorted part is 2 and 5. Since 9 is greater than both, it says at the end. The sorted part is 2, 5, 9. These are all the sorted part. The unsorted part are the 1, 5, 6. Again 1, 5, 6. 2, 5, 9. Sorted part, right? Sorted part. Next, we need to insert the fourth element. The fourth element is 1. The next element is 1. We compare it with the sorted part like 2, 5, 9. Since 1 is less than 2, yes, we insert it at the beginning. Next, we insert at the 1, 2, 5, 9. These are the sorted part. Sorted part. Sorted part. Next, 5 and 6 are the unsorted part. 2, 5, 9, 1 are the sorted part. Next we move on to the fifth element. The fifth element is 5. The next element is 5 compared with the sorted part. 1, 2, 5, 9. If 5 is greater than 1, yes. And 2. Greater than 1 and 2. But equal to 5. The next 5. So we need to insert it before 9. Sorted array is sorted. The sorted part is 1, 2, 5, 5. Because 5 is greater than 1 and 2 equal to 5. Then 9. These are the sorted part. Next we move on to the sorted. Move on to the sixth element. The sixth element is it means last element is 6. The last element 6 compared to the sorted part, like 1, 2, 5, 5, 9. 6 is greater than 1 and 2 and 5 but less than 9. So we insert it before 9. 1, 2, 5, 5, 6, 9. So you understood why 6 is inserted before 9. The sorted part is 1, 2, 5, 5, 6, 9. The unsorted part is nothing. All elements are sorted. The final sorted array is, after processing all the elements, the final sorted array is 1, 2, 5, 5, 6, 9. This is the final sort of the array. Don't worry about it. We are taking a next example. Example 2. In this example 2, I need to take array is 7, 3, 5, 8, 2. This is another example. First, start with the first element. The first element is 7. This is sorted part. 3, 5, 8, 2 are the unsorted part. 3, 5, 8, 2 are the unsorted part. 7 are the sorted part. We insert the second element. Compare 3 with 7. 3 is less than 7. Insert it before. The sorted part is the sorted part is the sorted part is 3 and 7. That's it. Okay, yes, the sorted part is 3 and 7. 5, 8, 2 are the unsorted part. Next, we move on to the third element. The third element is 5. Compare the 5 with 3 and 7. It's greater than 3. Yes. It insert before the 7. The sorted part is 3, 5, 7. This is the sorted part. Next, compare with the fourth element. Fourth element with 3 and 7. The 8 is greater than 7? Yes. We need to insert after the 7. 3, 5, 7, 8. This is the sorted part. The unsorted part is 2. Next, we move on to the next element. This is last element, right? The next element is 2. The 2 is less than 7. Compare the sorted array. 2 is compared with the sorted part. Like 2 is less than 3. Yes. We need to insert before 3. The sorted part is 2, 3, 5, 7, 8. This is the final array. Final sorted array. This is the final sorted array. 2, 3, 5, 7, 8. Hope you understood. Next, this is all about how to sort a element using a insertion sort. I hope you understood. If you like this video, please don't forget to subscribe, like and share and comment in this video.